Module 7, Chapter 4.4 and 4.5. Chapter 4.4 is functions defined by powers and roots. A function f given by f of x equals x to the b, where b is a constant, is a power function. This is like a polynomial function, except that b must be a non-negative integer for a polynomial function. In a power function, b can be any real number. If b is equal to 1 over n for some integer n is greater than or equal to 2, then f is called a root function. That is, a function f given by f of x equals x to the b, where b is a constant, is a power function. If b equals 1 over n for some integer n greater than or equal to 2, then f is a root function given by f of x equals x to the 1 over n, or equivalently, f of x is equal to the nth root of x. Now, in terms of domain, f of x equals x to the p over q, where p over q is in lowest terms. If q is odd, then the domain is all real numbers. If q is even, the domain is all non-negative real numbers. Now remember, in the expression x to the p over q, the p is the power and q is the root. And remember, you cannot take the root of you cannot take the even root of a negative number. So therefore, if the root is even, then the domain is all non-negatives. But if the domain is odd, then the domain could be all real numbers. Evaluate each expression without using a calculator. Now, the third root of 8 means what times itself 3 times would give us 8. And that would be 2, since 2 to the third is equal to 8. The third root of negative 27 would be negative 3, since negative 3 to the third is negative 27. Now, the fourth root of 1 means what times itself 4 times would give us 1. That would just be 1. The sixth root of 64 means what times itself 6 times would give us 64. That would be 2, since 2 to the 6th power is 64. Now, what about a negative out in front? Well, that's read as the opposite of the absolute value of 9, which would be negative 3. Now, what about the fourth root of negative 81? That means what times itself 4 times will give you a negative 81. Well, 3 times itself 4 times would give us 81. Negative 3 times itself 4 times would give us 81. There's not a number that times itself 4 times would give us a negative number. Therefore, that one is no solution. Now, evaluate each expression without using a calculator. Same thing. 25 to the 1/2 power. The 1/2 power means the square root of 25, which would be 5. 8 to the negative 2/3 power. Well, a negative power means 1 over, so that would be 1 over 8 to the 2/3. Well, that would be 1 over, if we do the root first, the third root of 8, and then we're going to square that. Well, the third root of 8 is 2, so that's 1 over 2 squared, which would simplify to give us 1 over 4. Now, negative 81 to the 0.5, that's like negative 81 to the 1/2, which is the square root of 81 and the negative still stays out front. Okay, notice if we would have wanted the negative to stay with the 81, then we would have used the parentheses. So this is like saying the opposite of 81 to the 1/2, which in this case would give us -9. Use your calculator to evaluate each expression. The square root of 30. Notice there's not a number that times itself will give us 30. So in that case, we're going to go to our calculator. The square root of 30. Remember, square root's right above the squared, which would give us 5.477. The third root of 50. Now, third root on your calculator, what you've got to do is go into this math menu. Third root is option number 4. Third root of 50, which gives us 3.684, depending on what they want us to round to. The fourth root of 32, now, we don't have a button. Remember, in this math menu, we don't have a button for the fourth root. So what we do is we're going to use this option number 5, the generic any root. But what you've got to do is you've got to do 4 first, then go math 5, and then enter what it is that you're taking the fourth root of, and we get 2.378. Now, use positive rational exponents to rewrite each expression. Assume all variables are positive. Well, the radicand, or the part under the radical sign, is x plus 4, and that's going to the 1/2 power. The second one, the radicand, is a to the 7th, so we do a to the 7th. The root is 3, so we're going to call that a to the 7 over 3. Now the fourth root of x squared, the radicand is x squared. And if you want to think about that as being to the 1/4 power, that would give us x to the 2/4 power, which would simplify as x to the 1/2. Now let's look at the graphs of even root functions. F of x is equal to the nth root of x, where n is even. That would include the square root of x, the fourth root of x, the sixth root of x, and so forth. The domain is all real numbers greater than or equal to 0. If it's an even root, you cannot take the root of a negative number. The range, if you take the root of a non-negative number, the range is going to be a non-negative number. Notice for all of these, the blue line is the square root of x, the pink line is the fourth root of x, and the green line is the sixth root of x. Notice in all the cases that the function is increasing from 0 to infinity, and it's also continuous from 0 to infinity. Now for odd functions, f of x equals the nth root of x where n is odd. These are the third root of x, the fifth root of x, and so forth. And then we continue out in both directions. Now in all of these cases, the domain is all real numbers. The range is all real numbers. It's increasing on the entire graph, and it is continuous on the entire graph. All right, now let's look at graphing power functions. Graph f of x equals x to the b, where b is 0.3, 1, and 1.7, for x is greater than or equal to 0. Now remember, our power functions, if it's an even, it's a parabola shape. If it was an odd, it was the S-shaped thing. But what about if b is a fraction or a decimal? Well, if f of x is equal to x to the 0.3, let's pick a couple of points. If x is 0, 0 to any power is 0. If x is 1, 1 to any power is 1. If x is 2, now we've got 2 to the 0.3. Well, we're going to have to do all of these on our calculator. if we're going to use our calculator, let's just go ahead and use it. So y equals x to the power of 0.3, press a graph, so we get our little x squared, or our x to the b, where the graph goes off to the right. Now if we wanted to pull out those table values, we could go to second table. We can scroll up and down. If x is 0, y is 0. If x is 1, y is 1. That was this point and this point. And then it just sort of goes out from there. For the second one, it says f of x is equal to x to the 1, or f of x is equal to x. Well, remember, now that one's linear. That's our power function with degree 1. If x is 0, y is 0. If x is 1, y is 1. Or you could look at that as y-intercept is 0, slope is 1. So that one takes off that way. The third one, f of x is equal to x to the 1.7. Same thing, I would just pull out my calculator, get our values. We know that 0, 0 is going to be on there. We know that 1, 1 is going to be on there. Now let's just find out where it goes from there. So we go to f of x equals x to the power of 1.7. Graph that. And now we've got this little parabola-shaped thing up here. Now remember, on this one, if your power is a fraction, then it goes off to the square root side. But if this is a number greater than 1, then it's going to take off like our parabola function. Okay, find the domain of each function. If f of x is equal to the square root of 4x plus 12, remember we said the domain of a radical function, the radicand, the part under the square root, cannot be negative. So what we've got is 4x plus 12 has got to be greater than or equal to 0. Solving that, subtract 12 from both sides, divide both sides by 4, and we get x is greater than or equal to negative 3, or interval notation would be from negative 3 to infinity. Now, if we wanted to verify that on our calculator, what we would do is come in here and do the square root of 4x plus 12, graph that, and notice the graph only appears from negative 3 to positive infinity. Now the second one, g of x is equal to the third root of negative 8x plus 8. For the third root and any odd root, x could be anything. The radicand can be anything. So in that case, the domain would be all real numbers. Now, for chapter 4.5, this is equations involving root functions. Recall, you have solved linear equations like 3x plus 5 equals 4 times x minus 3. We have solved quadratic equations. Remember, for quadratic, the first thing we do is we try to factor it. Let's see if that'll factor. 3x and x, 5 and 1. That won't work. 1 and 5. That won't work. So if it won't factor, we do our quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we're going to look at solving equations involving radicals, like the square root of 11 minus x is equal to 1. Now before you start solving these equations, there's a power property that we need to cover. If p and q are algebraic expressions, then every solution of the equation p equals q is also a solution of the equation p to the n equals q to the n for any positive integer n. Now, this property does not say that the two equations are equivalent. It says the new equation may have more solutions than the original. Okay, it says every solution to this is also a solution of the the one that we square or that we cube, the values that are solutions of the new equation, but not the original equation, are called extraneous values or extraneous solutions. Think extra. They don't really work. Okay? Now, to solve an equation, we're going to isolate the term involving a radical on one side of the equation. Then we're going to raise both sides of the equation to a power that will eliminate the radical or rational exponent. So if we have a square root on one side, we're going to square both sides. If we had the third root on one side, then we're going to third both sides. If we had the 1/4 power on one side, then we're going to take that to the 4th power. If a root is still present, repeat the previous two steps. And then we're going to solve the equation that's left. Now, because we squared both sides or because we cubed both sides, the power property says that we must go back and check each proposed solution in the original equation. If it works, then it's a solution. If it doesn't work, it's what we call extraneous. So, the square root of 11 minus x equals 1. First thing we're going to do is get the square root on the side by itself. So we'd get the square root of 11 minus x equals x plus 1. We've got the square root on the side by itself, so we're going to square both sides. Well, when you square this square root, those cancel, so the left side becomes 11 minus x. The right side is x plus 1 squared, which is x plus 1 times x plus 1, which if you FOIL that out and combine like terms, we would get x squared plus 2x plus 1. Now notice this is quadratic. So to solve a quadratic, we're going to set it equal to 0, add x to both sides, subtract 11 from both sides, so we get x squared plus 3x minus 10 equals 0. Now this one's going to factor. X plus 5, x minus 2 equals 0. So x is negative 5 or x is 2. Now let's check it. Does negative 5 work? When we plug in negative 5. 11 minus a negative 5 is 11 plus a positive 5, which is 16. So the square root of 16. Minus a negative 5, so that's going to be 4 plus a positive 5, which is 9. 9 on the left side, 1 on the right side. That doesn't check, which means negative 5 is not a solution. Let's try 2. We get 11 minus 2 is 9, so that's the square root of 9. Minus 2, which would be square root of 9 is 3, minus 2, which is 1. So we get 1 on the left side, 1 on the right side, which means 2 works. So technically, our solution is just 2. Okay, let's do another one. This one's a cube root. So solve the equation. The third root of x squared plus 3x equals the third root of 5. Third root x squared plus 3x is equal to the third root of 5. Now, our power property says, sure, we can go through here and third both sides. This side, third and the third root would cancel, so we would get x squared plus 3x. The third root of 5 cubed would just give us 5. Now, remember, because we took both sides to the third power, we need to go back and check our solution. But this is quadratic, so we get x squared plus 3x. Set it equal to 0, we get minus 5 equals 0. This one's not going to factor, so we could do quadratic formula, or we could just do our, let y1 be the left side, x squared plus 3x minus 5. Let y2 be the right side, which is 0. Graph, second, calculate number 5, enter, and we get our first solution is x is 1.19. Then we do it again. Second, calculate number 5. Enter. Move your cursor back so it's closer to the other point. Press enter, and we get negative 4.19. Okay? Let's do another one. Solve the square root of 2x plus 3 minus the square root of x plus 1 equals 1 using your graphing calculator. Now this is one of those that would have to square both sides and then simplify and square both sides again. So in this case, it's easier to just do it on our calculator. So we go to y equals the square root of 2x plus 3, close that, minus the square root of x plus 1, close that, and then the second equation would be is equal to 1. Graph that. There's our first equation going through there. There's the second one. Looks like it crosses in one point. Second trace, number 5, enter. And we get a solution of x is equal to 3. Solve the square root of 2x plus 5 equals 11 on your graphing calculator. Okay, so we get y equals the second square root of 2x plus 5 is equal to 11. Graph that. Now when we look at this one, you notice there's the first one. We don't even see the second line, but remember 11 is going to be right up here. So let's go to zoom 0, which is zoom fit. There's just a better window. There's that one coming through. There's that one, y equals 11. We need way over here, so let's go to our window. Let's change our x value to maybe window 60. Finally, we hit it, so we do second, calculate number 5, enter. And we get x is 58. This is one of those that probably would not be so bad to do because you've got the square root of 2x plus 5 equals 11. Square both sides. 2x plus 5 is equal to 121. Okay, so we'd get 2x is equal to 116. Divide by 2, so x is 58. Then when we check it, 2 times 58 is 116, plus 5 is 121. The square root of 121 is 11, so 58 would be our solution. Now, if we were doing this one, the square root of 2x plus 5 is less than or equal to 11. Well, on our calculator, we're going to look to see, well, the 2x plus 5 graph is less than 11. It's below 11 from 0 all the way up until where they intersect. So in that case, we would say that the solution would be from 0 to 58. Then we'll put a bracket because of the or equal to. Same thing on that one. The square root of 2x plus 5 is greater than or equal to 11. Well, the graph is going to start rising above that 11 line once we hit that 58. So in that case, we would go from 58 to infinity. Now, what about this one? X to the negative 2 plus 3x to the negative 1 minus 4. Well, if we wanted to just plug it in our calculator, we would get x to the power of negative 2 plus 3x to the power of negative 1 minus 4. And then y2 would be 0. I'm going to go back to zoom 6. So there's that graph. Now remember, x to the negative 2 means 1 over x squared. 3x to the negative 1 means 3 times 1 over x minus 4 equals 0. And we've got a couple of different ways we could do that one. Okay, we could come through and say, well, we know it crosses the x-axis to 0. It crosses it here and here. Second, calculate number 5. Enter. Well, first curve, we need to move left or right. It starts on 0, which means it wasn't pulling it off. So left first curve, second curve, guess. So we know that it crosses the first point at negative 0.25. Second, calculate number 5. Okay, the second time we're going to do second, calculate number 5. This time we want to make sure we're on the right side of that vertical asymptote. First curve's okay, second curve's okay, guess. Hit enter, and that would give us x is equal to 1. You are now ready to complete this section of homework on my math lab. And once you have taken notes on these 4 sections and successfully completed the homework from Chapter 4, you are ready to quiz on Module 7.